What's up, everybody? Welcome back to another Unreal Engine C++ training tutorial, where today we're going to be talking about TArrays. But before we actually get into the tutorial itself, let's actually see what we're going to be doing before we actually start diving into the code. So here I've got just a project that's already completed, so we can see what we're going to be working with today. What we're going to be doing is we're going to use something called the TArray in order to change up the way that we have been using the pointers. So if you remember last tutorial, which will be in the top right corner if you haven't seen it, we were using pointers to teleport to objects like this. What we're going to be doing today is obviously here I can spawn as many of these as I want, and we're going to look at one of them and teleport to whichever one we look at. Boom. So this is going to be done using, of course, TArrays like I mentioned, as well as using a little bit of math. Now this tutorial is probably going to be a little bit longer than the previous ones have been. I don't know. It took me a longer time to write it, so we'll just figure that out as we go. Like I said, this is directly coming after the previous tutorial, so the code that I have in this project right here is exactly the same code that we wrote in the last tutorial. So without further ado, let's talk about TArrays, because TArrays are the star of the show today. TArrays are useful containers that are functionally similar to standard vector in regular C++ with a few quirks. In other words, it's a dynamically sized array, meaning that it can change its size based on the needs of the program. It's an extremely powerful feature that needs to be used with care though, because if you use it wrong, it can cause memory issues and performance issues in your game. Alright. Let's get into the code now. Let's go. We're not going to worry about anything else besides the tutorial characters C++ and header files today. What we're going to do is we're going to add a couple TArrays and a function here. We're going to add a TArray, and the syntax looks very similar to standard vector if you've ever used standard vector. So we've got the array name, and we're going to store in this array the pointers to the projectiles that we spawn in the first tutorial. So I'm just going to call this projectile array. And then what we're going to do is we're going to get another TArray, and this one is going to be of type float, and this is going to be project.vals. I'll explain what this is for later. This is actually the best way that I've found to do this. If you've got any other ways, be sure to let me know. Either leave a comment or tweet at me. And the final thing that we're going to do here is we're going to add a function so we can teleport to the closest object that we spawn, obviously. All right, so now we're going to go straight into our onFire function, because that's where we had all of our teleportation functionality last time. So what we're going to do is we're going to get rid of the if-else statement. This else code is our teleportation code that we wrote last time that we're not going to be using this time. So I'm going to get rid of this if statement here. So basically, this is just the fire code that we have at the beginning by default, with a few modifications. So we've got tele to this is equal to the spawned projectile, and bCanTele equals true. So that's all we've got so far. Next, what we're going to do is we're going to add in an input component or an action binding so that we can have a separate button for teleporting. So what we're going to do is I'm going to come up here, copy this line of code right here. And if you're unfamiliar with player input component, I actually have another tutorial on timers where we messed around with player input component a little bit more. So here I'm going to call this teleport, and it's going to use the function telly to close. All right, now that's set up. Now we're going to write telly to close just so we can check to see if it works. I'm going to copy that because I'm lazy. And what we're going to do real quick is we're going to just add in a log message just to make sure that our action binding works. So we're going to go log temp, warning, and our text is going to say teleporting with a nice exclamation mark. Boom. So if we go ahead and save these guys and come in and compile, while we're waiting for it to compile, what we can do is we can come into the input settings. We have project settings right here. And if this is your first time coming in here, this is where you can basically change all of the project settings that go into your project, your supported platforms, the way you package it, your maps and modes. But what we're going to be doing is we're going to come into input and add a new action mapping. What we want to make sure is that what we type in right here is exactly the same string as what we have in here. Otherwise, it won't know what function you're trying to fire off. And I'm just going to set this to the right mouse button. Nope, that's the wrong one. Right mouse button, compile complete. So what we should be able to do is we should be able to fire off these projectiles. And when I right click, I'm not saying anything. That's because I don't have the output log open. I have a tab down here, but if you don't have this tab, what you can do is you can come into Window and Developer Tools and enable the output log, and it'll show up right here. As you can see, we've got teleporting right here. So when I right click, I get to see teleporting. But that's not necessarily what we want, because what we want to be able to do is we want this to fire off only when we can actually teleport. So if bCanTelly equals true. And there, I just set it to false and left it there. So we'll add in if bCanTelly come in and recompile that just to make sure that our functions are only firing off when we want them to fire off. We don't want to teleport to nothing because then we can get errors and crashes. And wait for this for a bit. All right, so when I come back in, I should not be able to get a teleporting message until after I fire the gun. Boom. That works. That's cool. It's done. Basically, all of our setup is done. So now we can actually get into the meat and potatoes of the tutorial, which is our TArrays. Remember how I was just talking about bCanTelly? We're actually not going to be using that at all. So we're going to get rid of every single reference to that. Get rid of that there. Get rid of it in the constructor, and might as well just completely erase it from the header file. Because what we're going to be using instead is we're going to be using the number of elements in the array to fire off our functions. All right, so now what we're going to do is we're going to reserve some space in our arrays so that every time we add something, we don't have to reallocate memory. And this is something that you want to do carefully. You want to be able to balance this number according to what you're trying to do, because if you allocate too much memory, then you'll have a lot of giant memory blocks that are being held empty, basically, and useless. So we're just going to reserve 5 spaces, 5 elements before it has to resize. And resizing isn't the end of the world for these arrays, but the least amount of the smaller number of reallocations that we have to make, the better. And why am I getting an error there? Projectile.vals. Projectile.vals. There we go. That works. And now what we have to do is we have to add our bullets to the array after it gets fired. So we're going to go and type in projectile array dot add, and we're going to add telly to this because this is just an array made of nothing but telly to thises. Boom. So that's easy. Now we're going to come into telly to close. It's optional. You can leave this debug message in there, but I'm gonna take it out because we don't need it really anymore. We verified that this function works. And like I said before, telly to close, this is actually going to involve a little bit of math, a little bit of vector math. So if you're not comfortable with vector math, I'd suggest brushing up on that. I've got a link in the description down below because we're going to be using the dot product, which is fairly standard. And let's go. Basically what we're going to be doing is we have to tell which direction the player is looking. And the best way that I've found to figure that out is to take the dot product of the direction that the camera is looking and the vector that connects the player's location to the location of the object on the screen. And the higher the value of that dot product, the closer it is to that looking direction, if that makes any sense. Hopefully it does. Let's get started writing the code. Maybe it'll make sense to you once we start writing the code. So we only want this to fire off if we have something in the array. So if projectileArray.num is greater than 0, then we're going to run the code. First, what we're going to do is we're going to take in the direction that the player is looking. So look direction is equal to, I'm going to get the first person camera component and get the forward vector of that. Next, what I'm going to do is I'm going to take in the player location. And I'm just going to get actor location. And then from here, I'm going to write for loop that's going to iterate over projectile array. Once again, if you're unfamiliar with the way that this for loop has been constructed, it's called a range-based for loop, and that will also be linked down in the description down below for your convenience, I guess. It basically just says for I inside of projectile array, and if I hover over I, it'll show me that I is actually going to be a tutorial projectile pointer. So it's going to iterate over all of those pointers, basically. So for each element in the array, what I'm going to do is I'm going to calculate a dot product value. I'm just going to call it dot val. And to do this, I'm going to use fmath, which is a library that we haven't used yet in this tutorial series, I do believe. And we're going to actually use the absolute value, because the absolute value is going to be probably the best way of doing this, I could imagine. Either way, let's go. So we're going to take the absolute value of the dot product. You know what? No, let's not use the absolute value, because if we use the absolute value, then what can happen is we can accidentally teleport to an object behind us when we're looking in front of us. So we're not going to use the dot product, or I'm sorry, we're not going to use the absolute value. So we're going to take the dot product of look direction, and then we're going to create a new f vector. And this f vector is going to be from player location minus the location of I. Simple enough. And projectile dot vals, we're going to add this dot value to this projectile dot value array. So what's going to happen is for each vector, or I'm sorry, for each element, for each actor in this projectile array, what we're going to do is we're going to compute the dot value between the player's direction and, I'm sorry, the player's looking direction and his location versus the actor's location, and we're going to store that value into another array. So what's going to happen is the first element in the projectile array will correspond to the first element in the projectile dot value array. A little bit more complicated than I would like to have it, but this was actually the best and easiest way for me to go about it. There are other options, I'm sure. I wasn't able to get them to work though. Moving on. What we'd like to be able to do is, since TArray is similar to standard vector in regular C++, what you would like to be able to do is go ahead and say something like this. int32 highest index is equal to projectile dot values dot max. But that's not going to work because max returns the maximum number of elements in the array. It doesn't give us the maximum value found in that array, and we don't actually have a function that does that like you would have in standard vector. So what we're going to do is we're going to have to write our own, which is a little bit of a pain, but it's not as hard as you'd think. So I'm going to comment that code out, and I'm going to come back into the header and add in another function. This function is going to get us the highest value in the array. I'm sorry, it'll get us the index of the highest value in the array. So then we can use that index in order to grab the values that we want. We'll talk about it. So it's going to be a const int32 index of max, and what I'm going to do is I'm going to pass it a const TArray of floats, and it's going to be a reference. We always want to pass TArrays in by reference when we're passing it into functions, and that's for performance issues. We can talk about the performance of passing in via reference versus straight up value any day, but most of the time you're going to want to pass it in by reference, and I'm passing it in by const reference this time because we're not going to be changing any of the values in the array, and we don't want the function to be changing the values in the array at all. So here I'm going to copy this again, but except this is going to be const int 32, index of max, and we're going to pass in const TArray. Same thing as in the header file. And this algorithm, it's not really important for talking about TArrays, but it's something that we're gonna have to be able to write in order to get there. So int 32 highest index. I'm just gonna set that equal to 0 for now. And usually what I would like to do in this situation, I'm going to use a for loop. I'm going to iterate over this. I'm going to iterate over this projectile dot value array. And usually what I would want to do is come in and use use an iterator or a const iterator. So it is equal to array dot create iterator or create const iterator. However, I couldn't get them to work for me when I was writing the tutorial. So what I'm going to do is I'm going to go the old school way and iterate them over value. So int 32 counter is equal to 0. And from counter less than array.num. And then increment the counter. If the counter is greater than 0, and then here's where our algorithm is going to come in. It might look a little funky to you if you've never heard of lambdas, because that's what we're going to be using. We're going to be using a lambda, which is basically a function that I'm writing in one line, if that makes sense. That's never going to be used anywhere else. Once again, link in the description down below. That'll help you out if you don't understand lambdas or lambda syntax quite too easily. It's a little funky, but it actually works out tremendously well in this case for us. So that way I don't have to write 4 functions just to get this thing done. Return, ooh, can't type today. Return array at counter. And here it is where we're actually going to be able to reference certain values in our array via index, just like we would be able to a normal array, or a normal C-style array, if you will. Which is why we're grabbing the index. Let's see. Okay, yep, here we go. Had to check my notes, make sure I'm not going crazy. Highest index is what I called it. There. If, all right, there we go. Then index is equal to counter. But except I named that value highest index. Ooh, there we go. I feel like I'm losing it. Return highest index. Ooh, that function is done. It is written. And basically all this is doing is it's iterating over our array of dot values and grabbing the index of the highest value. So if we call index of max and pass it in our projectile dot values, boom, there we go. Now we can continue on with our lives to the easy part. Here we can set actor location and rotation, just like last time. And we can grab projectile array at highest index. And we can get actor location. And then just like last time, just gonna get control rotation for our rotation around. We're just gonna rotate around the same point, I guess. All right, so here we set our actor location and rotation, and then what I'm gonna do is we're gonna delete all of the actors in the array, completely wiping out all of the evidence, I guess. So for auto actors, I'm using another range-based for loop. It works great for cases like this where we've got containers that support the feature. And we're just going to go actors destroy. Boom, that's easy, that's done. Now what we're going to want to do is after this if statement right here, because we want to do this regardless of the statement here, we're going to empty out both of the arrays. Just to make sure that we have a good foundation for the next time that we use this function. Projectile dot vals. And now what I should be able to do is I should be able to save and compile. Hopefully I get no compile errors because it's not going to be fun if I do. And even if it does compile, I'm actually using Unreal Engine version 17 or 4.17.1, which just came out a couple days ago, so I'm not too confident in its stability right now. It might end up crashing on us when we use the function, but it's okay. We'll load it up and try it again. So I'm going to spawn, oh, and exactly, I called it. So in this sort of scenario, it's really easy. I'm just going to rebuild from Visual Studio. And I figured out why. It actually compiled this statement right here. I don't have to change that. Nope. Compile. And then open it back up from the Visual Studio project. It crashes from time to time. The engine doesn't seem to be that stable all the time. With new hot fixes and bug fixes, the kinks will iron themselves out over time. Now let's try this again. Spawn 1, spawn 2, spawn 3. And now I can look at the closest one, or let's look at this one, and teleport to a different one. Okay, that was weird. All right, let's try that again. You know what? Maybe I did need the absolute value in here. fmath abs. I'm going to take the absolute value of all of this giant nonsense here. Recompile that. This is what I get for changing it up in the middle of recording. Go, go, go. You can do it. Boom. All right, let's try this again. 1, 2, 3. Which one am I going to look at? This one. Boom. Okay, yep. Went to that one first try. Let's look at that one. Yep. Now, the only issue arises when you have some situation like this where maybe the game is moving faster than you'd like it to, and you just teleport to the middle and it just picks one, because it looks like the middle to the player, but to the computer they're exactly the same, or they're totally different. Now we can actually improve performance just a little bit, even though this already works. What we can do is we can say if projectile array dot num is equal to 1, then we don't have to do all of this math here. All of this math is just nonsense as far as it's concerned, because we only have one element in the array. So I'm going to set actor, location, and rotation. And instead of projectile array at the highest index, we're just going to go at the zeroth element, because remember, the first element is index 0. And then projectile array at 0, destroy. Now we're going to want to change this up a little bit. We're just going to change this to if it is greater than 1. We're going to, oh, I hit compile before my last change. If we run the code as of right now, it'll run this statement, and then it'll run this statement. But if we change this to an else if statement, then only one or the other will be run. Small performance gains, probably unnoticeable in the grand scheme of things, but the little performance boosts do add up over time when you're talking about a large scale project. All right, and hopefully if I come in here, that didn't break anything. Look at boom, boom. And look at that one. Boom, it's done. Yay, and it only took 30 minutes. Oh my God. Yeah, this definitely was a long one. If you stuck around this long, thank you. It's really cool. Hopefully you learned something. Yeah, and stay tuned for next time, and we'll have some other cool tutorials. But for here, I am out. Peace.